All right, we are going over the 7.3 homework, making sure we're on the same page. We are solving for this guy. Tangent squared. First thing I did is took square root. Go with that? Okay, so square root goes away, so then I get tangent of theta equals the square root of 1/3. Well, I can't, the square root of 1 is 1, and the square root of 3 is square root of 3. Okay, so I could rationalize that by multiplying the top and bottom by radical 3. But what I really know is this. I don't really need to rationalize it. It's tangent. Okay, so when I do inverse tangent here, I'm thinking about where on my unit circle is tangent is y over x going to get me 1 over radical 3. Or in other words, where is my x radical 3? All right, it's plus or minus because I took the square root. Then it was just a matter of going to my unit circle and thinking about everywhere that x is radical 3 and my y is 1. It's at those 4 spots. Other questions on those first few? We good? There's 21 and 22. Yes, ma'am. 22. Yep. Started off on 22. I got rid of the square. So to get rid of the square, I took the square root. So the square root of 1 is plus or minus 1. Then I did inverse sine. So I thought to myself, where is sine going to get me plus or minus 1? That'd be at the top of the circle and the bottom of the circle. Pi over 2 and 3 pi over 2. Then we've got a 3 in front of my theta. So the 3 in front of my theta means 3 times around, 3 full cycles. Okay, so to get a second cycle, I had to add 2 pi. I got a common denominator, so I added 4 pi over 2 to those answers. I got those two. I added 4 pi over 2 to those two answers, and then got that. Then to finish that thing, I divided everything by 3, so it's like multiplying by 1/3. I got those answers in the end. You find your mistake? Okay. Yes, ma'am? Can we go over 21? I would love to go over 21. Oh, let's just start from scratch. All right, let's look at 21. So first thing we're going to do is we don't like secant. So if I don't like secant, I could rewrite this as cosine. And it seems kind of strange, but when I do the reciprocal and make it cosine, I don't have to take the reciprocal what's inside the parentheses. Okay, it's going to stay 3 theta over 2. And that's going to be equal to negative 1/2. All right, so it's like answering the question. Now we're doing inverse cosine. Where on my unit circle is my x going to be negative 1/2? Okay, so x is going to be negative 1/2 at 2 pi over 3 and 4 pi over 3. Good to there? I went through with secant, so it would be the same thing, though. If I did secant, when would x get you negative 1/2 would still be the same thing, right? Because secant is just a reciprocal. I would want x to be negative 1/2, so when I did the reciprocal, it would get me negative 2. Either way is going to get me the same values. Okay, if you treat it as secant or cosine, it's still going to get you 2 pi over 3 and 4 pi over 3, because that's where x is negative 1/2, and so you flip it and it gets you negative 2. Oh, I did it wrong. Okay. I did like pi over 3 instead of 2 pi. Okay, we want it negative, because the first answer was negative. You're good to this point then? All right, we've got this 3 theta over 2. This 3 theta over 2, you can think about what that means. That means you're going around 1.5 times. All you really need to care about doing is saying, oh, I'm going around more than once, okay? As long as you know you're going around more than once, you know that you need to add 2 pi to the mix. Okay, I'm adding to something with 3, so I need to add 6 pi over 3. So I'm adding 6 pi to 2 pi, I get 8 pi over 3. I add 6 pi plus 4 pi. Oh, no. Sorry. I hate when I change the slants to a slanted line. 8 pi over 3, and then 6 to 4, it's 10 pi over 3. And then to finish, I got to get rid of 2/3. So to get rid of 2/3, I'm going to multiply by, or 3/2, I'm going to multiply by 2/3. So I'm multiplying everything by 2/3, 2/3, 2/3, 2/3. When I do that, I get these 4 answers. Why does 20 pi over 9 not an answer here? It's more than 2 pi. And we should have known that by looking at our unit circle. Okay? If we look at our unit circle, I just got to pull up a unit circle. Hang on. If I look at a unit circle here, when am I getting those answers? So the first time around, I hit -1/2. Boom, I hit it once, and then I hit it a second time. That's what I got the first time around. And then I'm going around a half more. So if I go around a half more, I'm only hitting that answer a second time. I'm not hitting the other one. That is why I'm getting 3 answers and not 4. Okay? It would make sense as you did the problem anyways, but that is the reason why we only get 3 answers instead of 4. Other questions there, 21, 22? Here's 57, 58. See how you did. Questions 57, 58. Ask them, please. Yep, 58. On 58, we are starting off. On 58, we did inverse cosine. So I'm looking everywhere that cosine is 0. Cosine of 0 is up at the top at pi over 2 and down at the bottom at 3 pi over 2. Okay. Then I want to subtract the pi over 4. All right. So I always like to rewrite it with common denominators. That way my brain doesn't hurt as much. So this is 2 pi over 4. This is 6 pi over 4. But I'm subtracting pi over 4 from each of these answers. So then I get this. I get theta over 2 is equal to pi over 4 and 5 pi over 4. When I added or subtracted, are my both angles still on the unit circle from 0 to 2 pi? They are so far, so we're good. Then I got to get rid of the theta over 2. Remember, the over 2 means I'm going around half a time. Okay, I don't have to add more. I just need to see if they still fit on my circle. So to get rid of that 2, I'm going to multiply everything by 2. I get theta equals pi over 2 and 5 pi over 2. Are both of those answers on my unit circle? 5 pi over 2 is too big. Okay, we know it was going to be too big because I only went halfway around the circle, and 5 pi over 4 is more than halfway around my circle. So I knew that it wasn't going to be an answer when I multiplied it by 2. Yes, ma'am.
So this is just like a general question, but so when you have something in front of like your theta, so like the 3/2 on 21, do you always just add 2 pi? Like
if the thing that's in front of theta is bigger than 1, you're going to add 2 pi because you're going to go around again. Okay? If it's 3 pi over 2, you could just add 2 pi to all your answers and you'll figure out the ones that don't fit. If it were 5 pi over 2, I could just add 2 pi twice to each answer because it's going around 2 plus some change and just figure out which one's not going to fit. And so as long as if there's a number in front that's bigger than 1, add 2 pi. And you could keep adding 2 pi forever if you wanted to, but a whole bunch of them aren't going to fit. It just helps us to understand what's going on. Other questions, 57, 58? There's 59. Questions on 59? Last two, there's 63 and 64. See how you did on those. So again, we'd like everyone to be perfect, but if you're not perfect, you're still going to be fine because all we're doing from here until next Tuesday is reviewing. Okay, so keep that in mind as we go. Let's go to Bellwork and practice this some more. On Bellwork, we're solving for all the solutions on the interval from 0 to 2 pi, just like we've done every time. We look at this guy right here. What do we notice on this thing, Max? What do you notice first?
It's got a cosine.
Yep, I've got a cosine squared and everything else is sine squared. What could you do about that?
I use the trig identity to substitute cosine
Good. Use the trig identity. So we've got this trig identity right here. Sine squared plus cosine squared equals 1. And I like what he said. He's substituting for cosine squared. So he would solve for cosine squared. Oh, cosine squared equals 1 minus sine squared. So he can do a substitution. Everywhere he has cosine squared, he is going to substitute in 1 minus sine squared. So let's do that. Sine squared x minus 1 minus sine squared x plus sine of x is equal to 0. I don't know why I have these extra parentheses. It bothers me. All right. Good. We substituted in. Once we've substituted, Kara, what do you want to do next? I agree. So we've got sine squared x minus 1 minus plus sine squared x plus sine x equals 0. And I'm guessing everybody next combined like terms. Okay. You've got one sine squared x. You got another sine squared x. How many sine squared x's do you have? 2. 2 sine squared x plus sine x. And then I'm going to throw that minus 1 at the end because of what does that look like? It's a quadratic. Okay, it's a quadratic, so we're going to treat it like a quadratic, and that we're going to solve using the same steps we always do. Okay, a student earlier asked a good question. Why do we change it to U? It's, again, helping our brain out more than anything else, and this is a skill that you are going to do. It's a big part of calculus. There is something in calculus, a whole multiple sections called U-Substitution. Okay, you'll learn it next year if you take BC in November. If you take AB, we'll learn it in February. Okay, but it is a skill that we need to be good at. So just introducing it now is not a bad thing. Okay, just the idea. So we just made that U. Then it's factoring however you want to factor. Okay, I factor with borrow and payback. You factor whatever way you can do it. So I borrowed that 2. I'm going to factor 2 numbers that multiply to get me 2. So U plus 2, U minus 1. I factored, so then I borrowed the 2, so now I got to pay back the 2. So U equals negative 1, and U equals 1/2. Cool. Now what, Jack? Yep, you're going to plug back in for U. So instead of U, you're going to plug in what U is. U is sine. U is negative 1/2. There you go. We set them equal to each other, and then we solve. Inverse sine on both sides. Inverse sine on both sides. When is sine going to be negative 1? Point. Where is sine going to be negative 1? Sine is negative 1. Down there on the bottom, 3 pi over 2. That's one of my answers. And then I want inverse sine. Oh, not negative 1/2. It should be positive. Sorry. I just copied it down wrong. Inverse sine there. So when is sine 1/2? That would be at pi over 6 and at 5 pi over 6. Those are my 3 answers. Questions on something we did there? It's weird. The more practice you get, the better you're going to be. And that's ultimately our job today, is to get more practice. All right, so here's the activity we are doing. It is called a circuit training activity. It's just like doing some different things and running through it. Here's how it works. Okay, so you have a problem here on your paper. Number 1, 4 sine 3 theta plus 5 is equal to 9. Don't worry about this answers right now. You just do the problem. So we solve this problem, blah, 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 blah. We get an answer. Let's say we got theta is equal to, like pi over 6. And don't write this down, but you get an answer and you look for it. So you solve this problem. You find where you got that answer. Oh, there's one with pi over 6. I just made it up. Okay, but here's the answer. Okay, this is the answer to question number 1. All right, cool. So this is the second problem I'm doing. So I would put number 2 in the box. And then I would solve this problem. And then when I solve this problem, I'm going to look around for where the next one is. Oh, this is the next one. And I write number 3 in the box. And then I solve, and I keep going until the very last problem I gets this answer at the end. Okay, those will be our final answer. So it's a quick way for you to do a bunch of problems and to immediately be able to say, hey, I got this right, or hey, I got it wrong because it's not in there. Okay, everybody understand what you're doing? We're spending the rest of the class period working on that. Ask questions, talk with your neighbor, see what you're doing, but it's a way for us to make sure we are good at this. Go.